Here we will demonstrate the quad algorithm that was first used for Infinifrag 2. So I'm going to show you all the quads here. So in Infinifrag 2, instead of drawing individual 1x1 squares like you might expect, what we drew instead were entire quads of squares. So for example, this red quad here is just 4 vertices that are sent to the graphics card. This blue quad is just 4 vertices sent to the graphics card, etc. Now, when the user creates and destroys blocks, this causes quads to change. So for example, suppose we create a block here. Then the blue quad is now subdivided into this green one, this purple one, another purple one, and a yellow one. And if we remove the block, then those quads are merged together into one big one. This merging procedure happens lazily. Now, in this particular program, the world is broken into chunks, and quads are not merged across chunk boundaries. That's why sometimes you see quads that might be merged but don't appear to be merged anyway. So, so quads in this program are not merged across quad boundaries. However, in Infinifrag, on the client side, there were no chunks, so this resulted in a fewer number of quads. Now, when Zach was doing the level design, he took this into account, and when he made the mountains, he designed them in such a way that they used a smaller number of quads. Now, when I invented the quad algorithm, I made it a greedy algorithm, and what that implies is sometimes it can get sort of stuck. So for example, suppose we create 2 blocks here, so now we have this 2x1 quad on top. Now let's create another 2 blocks here, so now we have 2 quads on top, the red one and the green one. Let's create 2 more. So now we have 3 quads on top, and let's create 2 more. Now we have 4 quads on top, and let's see what happens when we put a block in the middle. So here, you might expect that we would just have a 3x3 quad, but unfortunately, there's no way that it can just merge adjacent quads together in order to accomplish that. So here you see the quad algorithm is sort of getting a little bit stuck. Now, Zach and myself discussed making a smarter version of the quad algorithm that would look for these kind of pathologies, but we decided that it just wasn't worth it.